Hey everybody, Mr. Judson here. So what we talked about last week, our shortcut for taking a derivative, we're going to have lots of rules and they all have names to them, and so I don't think I mentioned the name. We refer to this as the power rule. When I just take the power, or the exponent, multiply it times the coefficient, so n times c, whatever that equals, and then subtract 1 from the exponent. That's what we'll call the power rule. Okay? It's the most common rule that we'll use. There are other rules that happen a lot, but this is probably the most common one. When I say most common, you know, if there's 5 rules and you think 20% for each of those, okay, this might get used 25% of the time. So it gets used more often than the others, but it's not like it happens all the time. Right? So the power rule. Today what we want to talk about is the product rule. The product rule refers to multiplying two things. Like what if I had x squared times a cosine of x? I can't simplify that, right? So how do I do the derivative? It's not just 2x times, what did I say? If I said x squared times a cosine of x, the derivative of that is not 2x times a negative sine of x. Unfortunately, it doesn't work like that. So we're going to have to develop a rule for how to take a derivative when we are multiplying two things that cannot be simplified. Now, if I had something like this, well, there are two things being multiplied, but I could simplify this. I could distribute the x squared and call that x to the fourth plus 4x cubed minus x squared, and then I could go back to the power rule. And that's what I would normally want to do if the option was there. Today, because we're trying to practice the product rule, we're going to say, don't multiply this thing out. Use the product rule as a way to get the answer. Okay? So, let's figure out what the product rule is. So what I want to do is I want to take the derivative of f of x times g of x. So we're multiplying two things, thus the product rule, and the question is, what's the answer to that? Okay. Well, I need to go back to my definition of a derivative, because every time we do something new, that's what we start with. How do I develop a shortcut? Well, what I need to do is I need to take the limit as, I'll go ahead and use delta x today, as delta x approaches 0 of f of x plus delta x. So I'm plugging a delta x into both of these. So f of x plus delta x times g of x plus delta x minus the original function, which is both of those, f of x times g of x, divided by delta x. And now all I have to do is just simplify that. Yeah. Well, we're going to have to pull some tricks here. And fortunately, somebody long ago figured this out. This isn't me figuring this stuff out. I'm glad there's someone smarter than me to do this. But what I'm going to do is I'm going to add and subtract the same amount. Kind of like if I add 5 and then subtract 5, I really didn't do anything. I want to do something kind of like that. So what I'm going to do is this. The limit as delta x approaches 0, this fraction is going to get a little bit bigger. I've got f of x plus delta x times g of x plus delta x. And then I'm going to insert something here. I'm going to subtract f of x plus delta x times g of x. Now, why am I choosing that? Somebody else figured this out. All right, I'm just passing the information on. How they came up with that, I don't know. I mean, you'll see why. I mean, you'll see why it's important, but they had to do a lot of work before they figured this out. So if I just add something or subtract something, I need to turn around and add the same thing back. And then I've got minus this, minus f of x, g of x, all divided by delta x. Okay? So I subtracted something and then turned right around and added the same thing. So really I've added 0 to this function. I haven't changed its value. And now what I'm going to do is I'm going to break this into two fractions. This stuff over delta x and this stuff over delta x. Okay? So to do that, I've got the limit as delta x approaches 0. I'm going to make a fraction with all this stuff. And so I've got f of x plus delta x times g of x plus delta x minus f of x plus delta x times g of x. And then plus the limit as delta x goes to 0, because I'm creating a new fraction now. This is my common denominator, right? So the common denominator should be the same in both fractions. And then I've got this stuff. F of x plus delta x times g of x minus f of x, g of x. All right, so I'm going to factor out, in this thing right here, they both have an f of x plus delta x. So I'm going to factor that out. The limit as delta x approaches 0 of f of x plus delta x. I factored out of both of those. And then what I'm going to do is I'm going to have this fraction remaining. Since I'm multiplying, it's not really a common denominator for both. Right? Common denominators happen when you add or subtract. I'm not breaking this down into two separate fractions. I'm just factoring an f of x plus delta x out. You can extend the fraction bar all the way over if you want. I'm not going to do that because I'm trying to see something here. So what I'm left with is g of x plus delta x minus g of x. So I think we should see something there that looks a little bit familiar. Okay, over here I've got plus the limit as delta x approaches 0. Here I'm going to factor a g of x out of each of those. And so what I'm left with is f of x plus delta x minus f of x all over delta x. So at this point I can start writing down something that's a little bit easier to work with. If I plug a 0 into here, I just get x plus 0, so that's really just f of x. If I take the limit as delta x approaches 0 of g of x plus delta x minus g of x over delta x, that's just our definition of a derivative. So what I'm really doing, this limit of this stuff, I'm really just taking the derivative of whatever the g function is. And when I look over here, there is no place to plug in a 0 here, so that's just g of x. And if I take the limit of this, again, that's just my definition of a derivative. Right? The limit as delta x approaches 0 of all this stuff is just f prime of x. And I'm multiplying these things. So remember, our goal here is to figure out how do I take the derivative when I'm multiplying two things. So let me just rewrite that right here. The derivative, as I'm multiplying f of x times g of x, And what it's saying here is take the derivative of that, or no, write the first expression down, take the derivative of the second piece, and then plus the derivative of the first, and then the second piece, leave that alone. I'm actually going to rewrite this. I'm going to write the exact same thing, but I'm going to write it slightly different. I'm going to write f prime, I'm going to write this term first, f prime of x times g of x plus f of x times g prime of x. And now I'm going to say this a little bit different, okay? So I wrote down the exact same thing. This term was this one, this term is this one. And because I'm multiplying, I switch those two around. When I take the derivative of two things that are being multiplied, I want to take the derivative of the first piece times the second piece, plus, leave the first the way it was, times the derivative of the second. Let me write this exact same thing slightly different, okay? This is where you want to start paying attention. Write this part down. If I'm going to take the derivative of u times v. So in calculus, u and v are used a lot to represent two different expressions. So remember a second ago I said x squared times a cosine of x. We're going to do this problem in a minute. All right? So what I just said right here is take the derivative of the first piece, so u prime, times the second, plus, leave the first the way it is, times the second, the derivative of the second piece. This right here is what we call the product rule. So let's do that one problem. If y equals x squared times a cosine of x, what this rule is saying is to get the derivative, you have to take the derivative of the first piece, which would be 2x, times the second, and then plus, leave the first the way it is. Whatever's written here, write it there. So x squared. And now take the derivative of that second piece. Derivative of a cosine of x, we learned that last time, is a negative sine of x. And so my answer is 2x cosine of x minus x squared sine of x. There's the derivative. And that's not what we would have thought when we first looked at that problem. We thought, well, I'm not saying you guys thought this, but most students do. If you take the derivative of this, it's 2x. If you take the derivative of that, it's a negative sine of x. And so we would have got this piece and this piece, but we're missing, some of the other stuff. Okay? All right, so if I want to check this on the calculator, I want the derivative of this function. So second d of x squared times a cosine of x, comma, with respect to x, that's the variable we're using. And so I hit enter, and there it is. 2x cosine x minus x squared sine of x. All right. There's also going to be a quotient rule. If we've got something for multiplying, we've got to have something for dividing. But today, our focus really is just on using this rule right here. So I don't know if you guys thought this or not, but the question sometimes comes up, well, what if we're multiplying three things? Not just two. How does that work? Well, the rule is pretty close to the same. If I want to take the derivative of u times v times w, what I'm going to do is I'm going to write down those three letters 3 times. UVW plus UVW plus UVW. And so if I want to take the derivative of this, I got to take the derivative of the first times the other two, and then the derivative of the second times the other two, and then the derivative of the third times the other two. So you can imagine what this would be if we're multiplying 4 things, right? I'd write down 4 variables, plus 4, plus 4, plus 4, derivative of the first, second, third, and fourth. You know, we could probably write the rule ourselves. When you think of it this way, that's kind of the way this is written. Whatever those 2 variables are, write it down twice, because I got 2 variables. So once, twice, take the derivative of the first, take the derivative of the second. Okay? All right. Let's try a problem. All right, so I believe this is a problem that we could have done last week. If I just went ahead and FOILed this thing, so I got a list of terms, and they were all a number times a variable raised to the exponent, then I could use the power rule, okay? And honestly, if I was taking a test, that's probably what I would do on this problem, okay? The previous one that we had, x squared times a cosine of x, you can't multiply this, you can't simplify it. So there we have to use the product rule. But this I could use the power rule. So for today, let's not do that. Let's go ahead and use the product rule. But in the future, if you wanted to multiply this out and use the power rule, that would be fine. Okay? So we want to find the derivative. You guys go ahead and try this. All right, so I want to get the derivative, I want to take the derivative of the first piece, which will be 3 minus 12x squared, times the second piece, x squared minus 4x, plus, now leave that the way it is, 3x minus 4x cubed, and I want to take the derivative of this, which would be 2x minus 4. You can kind of see why I would probably want to do the power rule with this. I would have to FOIL this once, and then I could take the derivative easily. Here, I took the derivative, it was easy, but now I got to FOIL twice, so I feel like I have a little more work to do here than I normally would. But again, we're practicing the product rule, so you know, we're just going to humor ourselves for now. All right, so now we just have to simplify. So let's see, this is going to be, if I FOIL this, I'm going to get 3x squared plus, or minus 12x. Here I'll get minus 12x to the fourth plus 48x cubed. When I FOIL this, I'm going to get 6x squared minus, what is that, 12x, and then minus 8x to the fourth, and then plus 16x cubed. And now I just got to add up all the like terms. So a negative 20x to the fourth, and then I've got 48 plus 16, that would be 64x cubed. My x squared term, I've got a 3 and a 6, so that would be plus 9x squared. My x terms, I've got a negative 12 minus 12 more, so that'd be minus 24x. And there it is. And again, at this point, we can now ask some additional questions. We can say, what's the slope of the tangent line at x equals 2? Plug in a 2 and see what you get. What's the equation of the tangent line? Well, I've got the slope. I'd have to go back and plug 2 into the original equation to get a point, and then I would have a slope and a point, and I could write that line down, the equation of it. All right, let's try another one. All right, so remember, we're trying to use the product rule. Again, normally I would go ahead and FOIL this and use the power rule. It's a lot easier. But for today, we're trying to use the product rule, and in order to do that, I've got to have two things that I'm multiplying. So I should write this down as 3x minus 7 times 3x minus 7. Now I can do the product rule. All right, you guys go ahead and try. All right, so if I take the derivative of the first piece, that's going to be 3 times the second piece, which is 3x minus 7, plus, leave the first piece the way it was, 3x minus 7, times the derivative of the second piece, which is 3. So I really just have the same thing twice, right? So if I distribute this, I would get 9x minus 21. Over here I would get 9x minus 21. And so my answer must be 18x minus 42. There it is. All right, let's see if we can find the derivative of this function. So again, two pieces. There's the first piece, there's the second piece. So my derivative is going to be the derivative of the first, which is 3, times the sine of x, plus, leave the first the way it is, 3x, and then what's the derivative of the sine of x? That's a cosine of x. And looking at that, you really can't simplify it at all. If somebody was like, well, I like a factored answer, you could factor 3 out, but that's just more work. So I'm good right there. That's it. We didn't have to do anything additional to it. All right, now we're getting to some good stuff. I like it. Yeah, let's see if we can find the derivative of this function. All right, so really what I'm doing here is I'm just using the product rule twice. I got to find the derivative of this term to begin with, and it has two pieces. And once I'm done, I'll find the derivative of this, and it has two pieces. Okay? So f prime of x is going to equal, derivative of that would be 5, times the second piece, plus, leave the 5x the way it is, take the derivative of a sine of x, which is a cosine of x. And now I have to do the derivative of the second part. Now, when I do this, there's two ways to do it. One is, you could put a negative sign down and then find the derivative of x times cosine x. Or you could just think of that negative as part of the x term. I like to do it that way because, then it's fewer sets of parentheses here. I can get through the problem a little bit quicker. And so I'm going to think of this as a negative x times a cosine of x. So the derivative of negative x would be a negative 1 times a cosine of x. And then leave the first term the way it is. And now multiply by the derivative of a cosine x, which is a negative sign. So a negative times a negative is positive. And I get that right there. And then I'm checking to see if I have any like terms here. Here my sine function has an x, but here it doesn't, so you cannot add those. Here the cosine has an x, but here it doesn't. So I can't add those either. So that means I'm done. That wasn't too bad. All right, that's it. That's what we have for today. Product rule. So let me get you guys an assignment. All right, so here we go. We got assignment number 8. This is Monday's work. Page 129, we're going to do 5 to 10, 17, 18, 23, 33, 41, and 42. All right? Don't forget, you guys need to email me and let me know if you're going to take the retake. I really want to get all those by the end of today, Monday, okay? We'll talk about it in our class time, but I need to know so I can start getting things ready. All right, that's it. You guys have a good day. We'll see you later. Stay safe.